Okay, in this example, let's go and figure this out without a rule also here. And so looking at this, right, these expressions um, um, using a single exponent. So again, let's take a look. 2 to the power of 3 times 5 to the power of 3. And so we're going to try this without. Now look, they're not, the bases are not the same, but the exponents are the same. And so what seems to happen here, let's take a look. Let's write this out. Let's pretend we don't know any rules. So I have that times that, and then 5 times 5 times 5. And so what I notice is here, what I notice is that, okay, they're not the same base, so I can't just add them. A common mistake, right? Common mistake, because students do not understand, they've memorized. A common mistake turns out to be a student saying 10 to the power of 6 or something like that, right? Which we know is not correct here. And so in this case here, what we end up with, what I end up seeing is three groups of 2 times 5. If you look carefully, I see those groups separately there. So you have, if you somehow kind of rearrange them, because we know from commutative property that we could rearrange that, what I end up seeing is 3 groups of 2 times 5. So if you're creative and you're thinking about what this is, then what we have here is that this is just going to be equal to 2 times 5 to the power of 3, which equals 10 to the power of 3. And so if you look at that carefully, again, you can see how this can be rewritten this way. And so in this case, I see it has the same exponent. Really, the shortcut is then I can rewrite it this way as a power of 2, and then you end up with there's 33 times 7, which would be 21 plus 210. So I get 231 if we did that there, 231. And so in this case, this is 231 squared, or 231 squared, which you're going to leave it that we're writing it as a single exponent. And so what that leads us to then is the next theorem, right? And this theorem here, looking at this here, we see a to the m times b to the m is equal to ab to the power of m. And again, here's a proof. You can actually look at it. You can see the a and b, kind of what I wrote out, and they can be regrouped and paired up because there's a one-to-one correspondence between these here. And so you end up with, that leads you to saying a times b m times, because again, there's a one-to-one correspondence between correspondence between the a and b factors, right? They all match up perfectly, and so that's where you end up with that there.